Hi everybody, welcome. Thanks for coming to mvcconf. This session, as you can see, is going to be on improving ASP.NET MVC application performance. My name is Steve Smith. I am a senior architect with the Code Project, and you can find me online at my blog or on Twitter at @ardallis. What I want to talk about this afternoon for about an hour is how to improve website performance, how to measure it, how to profile your application, and I want to specifically touch on some tips and tricks for MVC applications in particular. I've been building ASP.NET websites since before the first version of ASP.NET came out. Most of my time the last few years has been spent on a very scalable application that serves up advertising and has to handle several hundred requests per second. I've basically been doing performance testing either for clients or with my own applications for about the last 10 years. And I want to share some of the things that I've learned and some of the things that I've learned not to waste your time on as well. So let's go ahead and get started. I'm hoping to get through this fairly quickly and save some time at the end for questions. And I think we're already about 5 minutes in, so let's go. So the first thing that is important if you're going to talk about performance in an application, particularly a web application, is to define what the performance metrics are. Typically, if you're used to working with clients and they tell you that they need their website built and you start asking them, well, what about performance? They're going to tell you, well, the pages should load fast. And if you press them, they might tell you that the pages should load instantly or perhaps in less than a second. That last one is actually getting close to what you need, but it's still not quite enough because you also need to understand what the load characteristics of the application are at the time when it's getting that kind of performance. So page execution time is important. Requests per second is also important because you need to be able to know that maybe your application can serve web pages in a few milliseconds when there's only one user, but when there's 100 users or 100 requests per second, which aren't the same thing by the way, you might have a very different set of performance characteristics. And then the last one that's important, particularly for web applications, is TTLB, or time to last byte. And time to last byte measures how long it takes for your web page to completely load in the end user's browser. And this plays more into how many different assets and resources is your page rendering, such as external CSS and script and image type files. That's also very important, and there's a lot of stuff that you can do to optimize that, but it's not something I'm going to specifically talk about today as we focus on the server side for the most part with ASP.NET MVC. So when you're defining these performance requirements, you might have something like this. You might say that for a given web request, such as the home page, you must return within a given time, either the TTLB or the page execution time, under some given load, probably defined as requests per second and or active users. You should also, in addition to those things, define the system characteristics. For instance, your application might run super fast when you've got a database that's 1 meg in size and has 100 records at most in any table. So you want to define that it's using the current production database or a database that has the same number of rows approximately as production has. And then you want to define any particular resource constraints that might also be there. Perhaps your system can in fact meet these performance requirements, but only when it uses 99% of the CPU on the database during the entire period of time. If your application's only doing one thing, maybe you're the Google homepage and you only have one thing that you can do, that might be okay. But if you have an application that tries to do many different things, as most websites do, it's probably not allowed for any one of those pages to use up all of the available resources and still consider itself to be meeting the performance requirements. Now the reason why it's important to define these performance requirements is because otherwise you don't know when you're done. It's very important that you not spend excess time on features or on improvements that aren't needed. Anything that you're spending time on that's already good enough is waste and should be spent on something that's actually adding some business value to the application. So that's why trying to define these performance requirements is important, and the sooner you can define them, the sooner you can build automated tests for them and then start running those tests. If you're starting off a website from scratch and you've got a handful of stories that say what it should do, you can write those first performance requirements right away before you even have a database, and start running tests that verify why yes, the home page that does absolutely nothing does in fact load in less than 2 milliseconds. Now over time, as you add to the type of feature set that your app is doing, those pages may get slower. But unless they get slower than your threshold defined in your test, you don't need to worry about it, and you don't need to waste your time trying to optimize it. Let those tests, let those performance requirements dictate when and where you start to apply performance tuning and making changes to your app to try and optimize it. You definitely want to avoid premature optimization. So for a performance requirement here, we might say that the index page must return within 1 second of page execution time, and we want to have 100 requests per second using the base database of the system, and we want this to happen with fewer than 200 database requests per second. So for the demos in this talk, I'm going to use the MVC Music Store application, which you can get from Codeplex, and it's an MVC3 application. So it's using Razor, it's using Entity Framework, it's got all the latest good stuff in there, and it's a fairly simple application, so it works well for the purposes of this talk. So once you've identified your performance requirement, the first thing that you're going to typically need to do is create a baseline. So in this case, you're going to record the scenario, set up a load test, run that test, and then analyze the results. Now there's a number of different tools that you can use to do this. Today I'm going to be using Visual Studio 2010 Ultimate, which has all of the things you would need in order to do this. So it has the web test tool, it has the load testing, it also has a profiler that we'll look at later on in this session. Once you've got the baseline, then that will tell you, what it is that you're going up against as you tweak it and as you make changes. And if the baseline, as I said, is good enough, then there's really nothing left for you to do. You can just, work on other features, work on other areas that need improvement. However, if your baseline is not sufficient and it's either not meeting the required performance or it's using too many resources to do so, then you can look at how to analyze that and how to make improvements. So with that, let's go ahead and take a look at the MVC Music Store sample application. And let's close this. So this is the MVC Music Store, and I've got it running on localhost. It's being served up by IIS. And in case you haven't seen it before, it's pretty simple. It lets you see some of these hottest items here on the front. It'll let you view by category various options. You can pick any particular album. You can add it to your cart. You can go find another one, and add it to your cart. And you can remove things from your cart, and you can go to checkout. Checkout's going to ask you to log in. And then once you log in, maybe I remembered my password. There we go. It'll ask you for this shipping information, and then you can put in this free promo code. And this won't work because it has validation, but you could say submit. And once you fill in all the required things, it'll add your order to the database. So if we look at this page, at this application, the MVC Music Store is a standard ASP.NET MVC application, and in the Solution Explorer here you can see it's got a number of different controllers, it's got some views, you can see it's using Razor syntax, it's got a shared layout.cshtml. This replaces master pages in MVC. We'll talk more about this later. We also have, this is using a number of models. The one that I think is most important that we're going to look at is the order model, and order just has a bunch of simple properties with some attributes on them to specify validation and things like that. When we want to test the performance of our application, we're going to identify a page, in this case we said it's the home page, that we want to optimize. And so the first thing that we're going to do is come down to our test project, and we're going to add a new test. So we're going to add a web performance test. And this will launch a recorder, which is using Internet Explorer. And we can just jump back to my page over here and grab that URL that I want. Yeah, okay. And come back to my page here, paste that in. And now it's recorded that page. And that's all we want to test. So we're going to stop that page. And it's going to create our test. It's going to detect dynamic parameters. It's going to see what all the requests that were made. And then as soon as that's done, it's going to verify that the test can actually run, and we see it passes. Now one of the things that we can do with this test is in its properties we could say that this particular URL has a response time goal of 1 second. And so we'll go ahead and set that and save it. And then we want to go ahead and add a load test. In the load test, we're going to try and have mirror the requirements that we set in our system. So in here we said that we want to have 100 requests per second, and we want to verify that by doing so we have fewer than 200 database requests per second. So to set that up in our test, we just need to create a new load test. And the load test starts off this wizard and lets you define these various settings. So we can come in here and we can say we want to test the home page. We're going to use no think time. Well, we'll use normal distribution of think time. And think time is how long things wait in between each thing. In fact, let's just go ahead and say there's going to be a 1 second think time. That'll make our lives easier here because we're trying to simulate a certain number of requests per second. And so if we have a certain number of users and a think time of 1 second, the math works out so that users equal requests each second. So if I want 100 requests per second, we'll just set it to 100 users. And we can leave the test mix alone. We can go add our new web test 1, which is the one I just created. And it'll be 100%. We could add more of them, and we could set up some mix of how they are, and I'll show you how that works in a minute. We can choose our network type to simulate. We're going to use LAN. Our browser to simulate, we'll keep it with IE. And then we can specify some different counters. So one of the ones that's important typically is SQL. And in this case, my SQL database is running on my same computer. But more frequently in a large application, you'd have it on a separate machine. You can still monitor that separate computer using these performance monitor counters from here. And so you'll be able to have everything in one location. And just to make sure we've got them, we'll also add IIS and ASP.NET. Next. We'll set a short warm-up period, and we really don't need this to run very long, so 2 minutes is really enough to let us know how it's doing. And finish. And we'll say OK. And now we're just going to run this load test. Now, I'm not sure what this is going to do to my live meeting and recording stuff because it's going to chew up my CPU. So if things flick out for a few minutes here, I'll just shut this thing down and be right back. But basically, when you launch a load test, it's going to start off all these agent, or a single agent in my case. It's going to show you all this data that's being collected every 5 seconds, showing you how the different parts of the system are behaving. So here's page response time. Here's the controllers and agents, which for me, they're all localhost. Here's the system under test. Again, that's localhost. Key indicators is really the one you want, so I usually make that the only panel I'm looking at. And then I want to add my SQL requests per second to this as well. So batch requests per second under SQL statistics is an important one to watch. And so my requirement here is that I want to be able to do about 100 requests per second. I want them to come back in less than 1 second. So my page time here needs to stay under 1 second. And we can see that right now it's averaging 0.2 seconds. We can see my user load is up to 100. So the warm-up time is where this was ramping up. And at the 30-second mark where the warm-up ended, it was at its 100 load. Pages per second, it's actually running a little bit lower than 100. Its last was at 84, but it's kind of close. I think there's a little bit of think time built into the test from when I recorded it that might be added there. I'm not sure. But it's close enough that it's a reasonable test. And then my batch requests is floating around 170 or so. So we could say, whether or not this meets the requirements would basically be, looking at those batch requests and comparing them to what the threshold was for my test. And in this case, we could say that if my limit was 200 batch requests per second with 100 requests per second, that I would be okay. I'm basically barely making it. There's about 2 to 1, as you can see, SQL requests per request. So we're going to shut this down. It takes a second to finish up. Now let's say that my requirement for this particular scenario was actually, much, much less. And I wanted to be able to get by with several hundred requests per second with much fewer database hits. Because typically your home page, you don't want to hit the database twice every time a user comes and hits it. That would mean that I would want to go ahead and find some way to tune this application. And we'll see how that works in just a moment. Now once you're done running a load test, you're going to be presented with this summary page. And the summary page, as you might expect, shows you some summary information. it'll show you the slowest pages. So if you run through a large number of pages on your application, this will help identify the ones that require your attention the most, because they'll jump out as being the slowest ones. It'll also show you the slowest tests, which aren't necessarily the same thing, because when you're running a load test, one of the cool things about the Visual Studio load test tool is that you can combine web tests, which are testing any particular web page, not necessarily even an ASP.NET page. You can run it against any web page on your system, or even on a remote system. But it can also run other types of tests, for instance, unit tests. So if you have a service that you don't want to have to drive through some web front end in order to test, you just have a unit test or an integration test that you want to verify is performing adequately, you can create a load test and put that into it. Or you can create a load test that includes several web pages and an integration test or a unit test that simulates some back-end processing that's going on at the same time. And then you can establish the mix between those. So maybe the unit test runs once for every 5 times that the web page runs, or something like that. It can be a very flexible way for you to test your system. Now this will show you the overall results over here. So we'll see the max user load was 100. It was managing 82 requests per second, etc., etc. An important one here is that the request that failed was 0. If you do this frequently enough, you'll find that sometimes when you look at this graph and you see errors per second, that if you're not keeping an eye on this, your pages per second or your requests per second may suddenly go through the roof, and your errors per second might be the reason why. It turns out that Microsoft has done an extensive amount of work to make IIS really, really good at serving up error pages. And so anytime you're trying to optimize your site to go faster, a sure way to do that is to make it so all it does is serve up 500 errors, and it'll do that faster than anything else. So you want to make sure errors per second stays at 0 or very close to 0. If there's like 1 or 2 errors as the site starts up or something, that's usually not worth worrying about. But anything ongoing during the test invalidates the test, so you should just throw it away at that point. The other thing you can see is various tables. So you can look at each test in a table. You can look at all your exceptions. In this case, there's a counter that it's not able to read. And then the details will let you zoom into a particular period in your application. So in this case, I added 100 users, and each one was only active for a very short period of time. So they all appear as little blips here. We ran through the first 100 users, and then we started off here, the next 100 users, the next 100 users, with a little bit of think time in between. If you had a longer running session with each user, these would appear as actual bars, as horizontal bars that indicate the time frame during which that user was active. And so you might find that in particular parts of your test where a set number of users were stacked up together, that they were causing some problem in your system. And then you can move this so that you zoom into different parts. So if you really want to see what was going on right here where this little blip occurred, you can see these are the actual virtual users that were doing stuff at that time. And you can slide this around any period on your test. Now this will also show you errors and other things. In this case, we don't really have any, so there's nothing too interesting there. So that's our baseline load test. And now we can come back here and we can say, well, did we meet our requirement? Well, yeah, we're just under 200 database requests per second, but as sometimes happens, the customers changed their mind and decided that 200 requests per second for 100 users is a little bit nuts. So they would really prefer that we get that down to something a little bit less. So now that we have our baseline, we've got something like this. You can see in a previous run of this that it ran with closer to 90 pages per second and 270 average database requests. You need to run these things sometimes more than once just to see how they work, and there's some margin of error. It might depend on what else you're doing at the time. For instance, recording things on Camtasia and broadcasting to several hundred people. These things can affect how your computer works. It can also make a difference whether you're talking to a remote or a local database. That often makes a big difference in how the app performs. So you want to make sure that your performance environment that you're testing is as close to your live environment as you can manage with your budget. The other thing that you can do when you run an application that records multiple things is you can see where are the slowest pages. And I showed you that earlier. This is an example of another test run that goes through the store and identifies where the slow parts are. And in this case, I'm running a different scenario called max load, where I'm just stressing this thing out to the max. And as I'm going through the store, I'm adding several items to my cart and then checking out. And in analyzing the code when I'm done, this is the time that these pages took. And each one of these pages is an add item to cart page. And this is the album ID. So that's telling me that that particular page is one that I could certainly look at as being something I could hope to improve. Now my home page here, you can see, is coming in still less than a second. So it's within my requirements. So it's not one I would necessarily want to waste any time trying to improve. But we'll go ahead and do so anyway. Once you've identified your slowest pages, then you can go and you can start tweaking things, and you want to apply a certain strategy to your thinking. You're basically putting your scientist hat on and making a hypothesis and then testing that hypothesis or that theory until you are sure that you've got the correct thing. And only then do you move on to trying to find the next bottleneck. It turns out that in any given system, for any particular test that you're running, there's going to be one and only one bottleneck. And anything else that you change in the system is not going to necessarily affect that bottleneck. So, if it's the bottleneck is CPU, or the bottleneck is disk, or the bottleneck is database access, if you go and double the memory on the system and the problem was, how many times it's hitting the database, that's not going to help any unless you're caching everything, which is reducing the bottleneck on the database. So, that's the important thing, is that you have to find the bottleneck, and then once you've found it, you need to alleviate it by giving it more resources or reducing how much you're using that resource, and then test again. And if you need to continue improving things, you need to locate the next bottleneck. So to tune a web application, which is the next step if you've determined that your performance requirements are not being met, first off, you need to define your goal. Second, you need to measure, which we've just done. And then if you find that you meet the goal, you're done. So you stop. Now ideally, you're going to automate these tests and run them on some periodic basis, perhaps every night, and all the ones that meet the goal just pass. If at any time something fails to meet the goal, then the next day when the developers come in, they're going to see a failed test on the build server, and they're going to look at that and address it, so that the next night, they're going to check in new changes to the code and they're going to fix it. In that way, you're never wasting your time trying to tweak optimizations into the system that aren't required, and that keeps you from making your application more complicated than need be. Because typically, if you build things the simplest way that will possibly work, usually the performance is good enough for most applications on most hardware. When it turns out it's not, then you can go in and change it. But almost always when you add some kind of an optimization, you're making your application more complex. If by definition, if you started out doing the simplest thing that would work, anything that you're doing that optimizes it after that is adding complexity to the system, which is incurring additional cost, both in the short term, if you had to add that change, and in the long term, because now someone has to maintain that and understand why it's not doing things the simple way. Assuming that your system does not meet the goal, then you need to form a hypothesis, look at the data that you've got, figure out what you think the bottleneck is, and make some change to the system. Now this is where having a system that's well composed into different classes that each do one thing, and configuration settings that are easily altered to affect how the whole system acts, these come in very, very handy. If you have a system that has, let's say caching implemented, and you've implemented caching on every single page of your application, or in an MVC app, on every single action of every single controller, you've got a different output cache directive that's stating the vary by param and the duration in seconds. And it turns out that you need to change that system-wide, because the customer says, well, I told you 5 minutes was good enough for the cache, but people are complaining, you need to make it 30 seconds. Well, if you did that everywhere, you're violating the don't repeat yourself principle, and you're going to have to go touch every single action of every single controller to change that number. And so that that's just one example of where you want to put information like that has to do with how you tune the system in one location, and make it so that when you have to change it, you can do that in one place, and then you can rerun your tests and verify that that did or did not make it so that you now meet the goal for that performance. Alright, so critical here is change only one thing. If you go in and you think, well, it could be any one of these 5 different things, and you change them all, then your system, you're not going to know which one was the one that caused the difference. So, typically if you're, for instance, doing what I just said, where you're running this on a build server and it's happening every night, it's probably going to run with whatever was checked in that day, and there could be multiple check-ins. As long as it's passing, that's okay. When it fails, you're going to have to figure out which one of those check-ins resulted in the problem. And that may or may not be something that takes a lot of time. If it's very, very rare that ever fails, it's probably not a big deal. If it happens every other day, then you're probably going to want to adjust your build system so that it builds on every single check-in if possible, or at night it builds using some kind of a quick sort algorithm so that it grabs the first half of the check-ins and runs it, and then it grabs the second half of the check-ins and runs it, something like that. So now let's talk about the common performance problems for web applications. The biggest one in most data-driven apps is going to be the database. Either you've got too many queries, which is very common, or your queries are not optimized. They need to have indexes, they need to have a lack of locks, they need to be non-transactional when they're using transactions. Things like that can easily improve the performance of your database access. If you're using an ORM tool, an object relational mapper like Entity Framework, Link to SQL, and Hibernate, any of those can also have issues and can also be optimized to make it so that they're not making as many queries to the database typically. The next one that's sort of related is network requests. Anything that's calling from your server to some other service or web service, and also anytime the client's browser is talking to your web server, those network requests add up quickly in terms of your overall page performance and the responsiveness of your website. If you can reduce the total number of network requests, make a chunky application rather than a chatty application so that it fetches more stuff in fewer calls, both from the client to the server and from your server to the things it needs, that will generally improve your performance. Another thing that's very simple but can be important is to make sure that your deployed applications are built using release mode. You also want to go into your web config and make sure that you have debug set to false in your web pages compilation mode. Those things will improve the performance of your application. Not a huge difference, but a significant one, a measurable one. There's a tool you can use that's available on Codeplex called ISIS. That's a ASP.NET control panel. It's still very much alpha code, so use it at your own risk. But one of the things that it has right now is it will show you in your production application here, it'll show you which assemblies are in the bin folder, what version they are, and whether or not they're a debug build. So this can be an easy way if you throw that out in your app. Do go ahead and secure it, because you're going to want to restrict this to administrators. There's some other things it does and things that it shows that you don't want open to the world. But one of the easy things it will do is it'll let you identify anytime you've got a debug build deployed out to your system. And also, if you're not sure which version you have installed on your production web server, it's also an easy way for you to see what versions of assemblies you've got. So make sure everything gets built in release mode. That's so insanely obvious and easy that you should always be doing that. And then the next one is one of my favorite topics, which is output caching, caching in general. Output caching, if you haven't used it with ASP.NET MVC, is done through attributes. And these attributes can be applied to the action methods of a controller, or you can apply it to an entire controller. And output caching can have a tremendous, dramatic effect on the performance of your application. And we'll look at an example of that in just a moment. Now, when you're looking at your MVC app and you're trying to decide which things are candidates for having output caching applied to them, generally you're going to want to look for things that are a read operation only, or that aren't doing any data access at all. We'll see in a few minutes that that can also have a dramatic performance impact, output caching those items. Things that you don't want to include are going to be pages that are doing writes. So if they're doing updates or deletes or inserts to your system, generally you don't want to output cache those. Also, if you have a page that is user specific, then you need to be careful about doing any kind of output caching on those pages as well. So in the example here, these are all controllers and actions from the music store. The first one is the home page, which grabs the top selling albums. And at first glance, this appears to be okay because there's nothing user specific and nothing being written here. Over here, we've got the shopping cart controller, and it has an index page that will show the current user their shopping cart, or will add an item to the shopping cart. And obviously either one of those are not things that you would want to cache, because you don't want one user to see another's shopping cart, or even worse, add something to someone else's cart. So let's have a quick look at how we would apply output caching and what effect that would have on our application. So we'll keep this same load test that we had before and look back at our controller for the home controller. And home controller has here our index. We're going to undo this one. We're going to comment that one out. So here's our home index, and we're going to apply output cache, and we're going to say duration equals, we'll say 60 seconds, and we'll say vary by param equals none. Now with that in place, if we run our load test again, actually let's not put that in place. We'll do it once the load test is running. It's more fun that way. So we'll run our load test again. It takes a second for it to spin up, grab all the counters. It's going to do the warm up for 30 seconds. We're going to go ahead and turn on the output cache before it even gets that far. So in this case it's doing, actually, you know what, I'm going to stop this. In this case it's doing a think time that's going to screw it up. So let me fix that real quick. So in our load pattern, we're going to change this so that the think time that's being used is 0. So we're just going to say off and set that to 0. And because of that, we don't really need 100 users. So I'm also going to change the number of users. We'll just make it 25. Alright, so now this is going to hammer this as fast as it can, which will be a much better example of how much it can do. And we should see much bigger numbers than we saw before. And I don't know if I built, so let me just also build. Okay. Alright, so it'll take it a second. That's the site's rebuilding. You can see there's a few errors occurred while it was rebuilding. That's perfectly natural. Pages per second now are running around 60. And one other thing that I changed there on the home controller was the data access that I was doing. Previously it was actually caching a little bit of that data access, so it was not quite as bad as it was out of the box. Now you can see it's running a little bit more batch requests per second than it was before in terms of per request. So this thing seems to have pretty much leveled out, and you can see that it's running now at about 63 pages per second with 190 database requests per second. So that's about 3 to 1 at that point. So on the home controller, now we're going to go ahead and turn on the output caching. So we'll do this and rebuild. And when that rebuild takes place, again, we're going to see something like this where it's going to stop serving for a minute while those pages get JIT compiled and all that stuff that happens when the app restarts. But then you're going to see a dramatic increase in performance because of the fact that we're now output caching that page. So we went from 60 something pages per second to now 225 pages per second. So that's what, a 300% performance increase. So we can get little 5% increases and 10% increases with other little tweaks, but pretty much nothing is ever going to give you a better performance improvement than simply output caching the whole page. And so if you can use output caching, then that should always be your first go-to thing in your app. It'll give you the biggest bang for the buck. Make sure if you're talking to your boss about your bonus, you want to tie your bonus to what percent you can boost the app. Show them a couple of little things that get like 1% and get them on board with that. Okay, I can afford that, and then go throw output caching on there and then see if he'll stick to that deal and give you that bonus. All right, so you can see this gave us a big boost in overall performance. There's a problem with this though. It turns out that even though it looks like, let's get back to Visual Studio, even though it looks like this home controller isn't actually doing anything personal to the user, if we go look at the page and come back to that home page, unfortunately it's got this cart here that's showing the number of items in the cart. Now if we could just convince the user that they don't need to show that 0 there or this admin link to any given user. I'm seeing the admin link because I'm logged in, and I'm also seeing the cart with the 0 because that's how many things are in my cart. And if I go and I add an item to it, we'll see now that that cart's being updated with the items that I've got in my cart. So having that output cache is a problem. In fact, we can see it right now. I've got 3 items in my cart, but when I go to the home page, they disappear. That's because of the output caching. If I turn off the output caching and then hit that page again, that bug will disappear, and I should see my my 3 items in the cart like this. So you have to be very, very careful with caching. It's very easy for you to introduce bugs like this, and especially these days, most applications have some kind of user-specific data on them, and so it's often the case that you can't cache the entire output of the page, and you end up having to cache just the data on the page. And so data caching is something else that you can add to your system that can improve the performance. Maybe not quite as much as output caching does, but significantly. Alright, so let's jump back to the slides for a minute. I always do that. Here's an example of what things look like after output caching. Just in another load test that I ran, we were able to get the batch requests per second down to 5, even though I was serving up 100 pages per second. So that's much, much better. So then the next thing that you can do is you can add data caching. Now, data caching is not anything specific to ASP.NET MVC. That's been around since the early days of ASP.NET. You generally want to apply it to read operations, and you can use this anywhere output caching can't be used. It's worth applying it at the repository level. I've got an article I'm working on that I hope to publish on my blog very soon that'll show how to use this pattern. But basically, if you apply the repository pattern already, it's basically a pattern where you create an interface and an instance of that interface that is for all your data access. Once you've done that, adding caching is very, very easy to do, because you can create a subclass of your repository that is the cached version. And that cached version of the repository can then be substituted for your regular data access version of the repository. And I'll show you that real quick right now, and then we'll jump into some more MVC tips. And then the last thing on data caching is, if you can, consider using SQL cache invalidation, or you can use a very short cache duration. Oftentimes even a 1-second cache can have a dramatic impact on performance if it's a resource that's being used more than 1 time per second. Alright, so let's look at this repository pattern stuff. So by default, the music store creates this store DB that's music store entities type, and then this get top selling albums down here just uses that instance and starts fetching stuff off of it using link. If we take this exact code here and we put it into a repository that we define, so we go and we create an interface called iAlbumRepository, we give it a method that says get top selling albums, pass it the count, then we can take that exact code and put it in here. This is our SQL album repository, and that exact code now just lives inside this method. Then we can go into our home controller. We can say, well, alright, we're not going to use this one anymore because it's tightly coupled to that particular this implementation right here. Instead, I'm going to use this one here, and this is still tightly coupled to an implementation because I'm newing it up right here. What you would want to do is you'd want to inject an instance of iAlbumRepository into the constructor for your home controller. And there's some easy ways to do that with an inversion of control container like Unity or Structure Map, but they're beyond the scope of this talk. So in this case, I'm just going to new it up, and we're going to switch which one we're using by commenting out different blocks. But the beautiful thing, once you have that IOC container in place, is that changing whether you're using a SQL album repository or, as we'll see in a minute, a cached album repository is simply a matter of going into one file and changing which instance you want to use when your class is asking for an iAlbum repository. So using this SQL album repository, we can rebuild. We can go back out to our home page and hit it, and these are the things that it's fetching, and they still work. Alright, so not rocket science there. But then the next step is to go to our repository here, and we're going to make sure that this is virtual so we can override it, and we're going to come create a cached album repository that inherits from SQL album repository, and we're going to do all of our caching logic in here. Now this is important because we're basically following the single responsibility principle here, or SRP, we're making sure that the only thing that our SQL album repository does is talk to the data store and get the data. It doesn't know about caching, doesn't know about error handling, doesn't know about logging. It does one thing, and that's it. Now if we want to add some functionality to it, we can subclass it, or we can use composition. In this case, subclassing is a little bit easier because it works well with various IOC containers, to make it so that some other class has the responsibility for, in this case, caching. And so we're going to override get top selling albums and do our caching logic. And there's a nice pattern that you want to use when you cache that looks a lot like this, where you want to check the item, verify it's null, you want to put in a lock, then you want to get the item again, verify it's still null, because if you hit this lock with, say, 3 requests and the first one goes in here and actually gets the thing from the database, when the next 2 come in, they should check the cache and see if it's there, and if it is, they can just leave with their result. Otherwise, if you don't put in a second check here, what will happen is every single thing that queues up on the lock is going to enter this system, and they're going to go and they're going to fetch the item from the database again, and you end up with a lot more database requests than necessary. Now in this case I'm hard coding the time. Don't do this, that's bad. But for demo purposes I've just put it in there as a 60-second time. And if we go back to our test controller, if we go back to our home controller and switch it up to use the cached one, we can go hit that page and refresh. And once it builds, you can see it still works. So now we're only hitting the database for this part of the page down here once every 60 seconds. The cart is still dynamic. So you can see, unlike with output caching, I've still got my cart showing here and not an empty cart that belongs to some other anonymous user. Alright, so that's how you can use data caching, and that's how you can use the cached repository pattern to basically take your repository, wrap it in a cached repository that does all the cache logic. And you can actually take all of this stuff. It turns out there's a lot of repeat code here. For instance, when I do get by ID, it looks like this. It looks very similar. The only thing that's changing here is which thing I call right there, and maybe how I generate the cache key. All the rest of this code is the same. So as soon as you've got that much code that's the same, you're violating the don't repeat yourself principle. There's an abstraction you can use to fix that uses a lambda expression to identify this particular method. And in my article that I'll post soon, I hope, I'll also show you how to do that. Alright, so now let's jump back to our slide deck and say, what about writes? So we've talked about reads. Reads are the easiest thing to optimize with caching. Writes are another story. The easiest thing to do with writes to improve your performance is to avoid blocking on them. Writes are often more expensive than reads in your system for various reasons, and so if you can avoid actually doing the write in process, in the context of that web request, then you can go much faster. One of the easiest ways to do this is to send a message using MSMQ or a bus like nservice bus, which uses MSMQ under the covers. You can just create a message that says, oh, this user created an order. And then instead of telling the user, your order was complete and here's all the order details and here's when you'll get it and everything else, you can just say, thank you for your order. You'll get an email confirming that it went through. And now some offline process can send that user an email whenever that picks up the thing, but that's out of band from your web server. Your web server managed to just write that message, say thank you to the user, and continue on serving up other requests. The other thing you can do with writes is you can use asynchronous calls on your server. This won't usually improve performance unless you're doing multiple writes to multiple locations, but it can improve scalability because you won't be tying up a thread. You can also use async and AJAX from the client so that you're making smaller requests to the web server rather than fetching the entire the whole page again. You can just make a jQuery or an AJAX callback that does an add item or does a checkout and has a much smaller payload. And also, if that particular thing takes a little bit longer, the users are usually a little bit more tolerant of that than the whole page being blank and not coming up. The other thing that's useful is to logically partition your reads from your writes. What that means is you might have 2 repositories. One repository that's only used for reads and another one that's only used for writes or commands. And the pattern that describes this is command query responsibility separation, or CQRS. You want to go and learn some more about that if you're interested in improving your application at high levels of scalability. Other tools you can use are profiling. There's a great profiler that's in Visual Studio. It'll give you output like this. It'll show you the hot path in a particular thing, so you can record a few steps. It's usually worth going and hitting your web page multiple times in order to get the profile data to be accurate, because the first time it's still caching things, it's still JIT compiling things. So if you hit the home page 10 times and then come look at this, you might get data like is shown here saying that 50% of my time was spent in my link queryable order by descending method, where I was getting those top selling albums. That's telling me exactly where to look to improve my performance. If I go and I try and optimize something that's not on that critical path, I'm probably wasting my time and I'm not going to get a significant boost. You can also check tier interactions using the Visual Studio tool. So for instance, when you run through a bunch of different pages, it'll let you see how many requests were made to each of those pages, and then as a result of those requests, how many database queries there were. So for instance, on the checkout page, I made 3 requests to it, but it resulted in 13 queries. That might be something I could try and optimize. Ideally, you'd like to get it down to 0 or 1 query per page. I already talked a little bit about async. There's some good support for async built into MVC. It's been there since version 2, I believe. Basically consists of using an async controller and then setting up async actions that start and then complete. I don't have time to go into that further, but it's certainly something you can investigate. Now, comparing the MVC version and the View Engine version, there's a recent blog post that talks about this. If you take the MVC2 template on MVC2 and you run it on a particular machine, you might get 8,100 requests per second. This is with no database, there's no authentication going on, it's just MVC. If you then take that same template and run it on MVC3, it's a different engine but the same exact code, you will get almost the same. You'll get 8,000 requests, so it's like a 2% difference. It's within the margin of error. So MVC3 is not significantly different performance-wise than MVC2 using the MVC2 template. If you then take the MVC Web Forms View Engine, the default template, on MVC3, that goes to about 7,500 requests per second, which is another couple of percentage point drop. And then if you use Razor, you'll see it's 7,100 requests per second. So you can see there is a little bit of a performance cost to using Razor, and some of the things that are enabled by default in MVC3 do take a little bit of performance, like some of the unobtrusive JavaScript. But they're not things you necessarily want to worry about. You can see MVC3 is still super fast, and all these things will just wash out as noise when you consider how they compare against something like your database access on most pages. So the main things that affect the performance of MVC3 include the client-side validation on by default and the Razor View Engine. A number of other things were improved, such as expression caching, URL generation, action lookups, and filter invocation. There's a few gotchas that mostly these two relate to caching. So the HTTP response.write substitution is something you could use in ASP.NET Web Forms, but if you try and use it in MVC3, it may not work. I'm told that it may be working with MVC3 and ASPX views, but it's not supported, and it's definitely not something you can use with Razor. There's also a caching issue with calling render action. If you call render action and you call an action that has an output cache attribute set, the entire page may then be cached, which is probably not what you would expect. So that's something to be aware of and look out for as well. A few other performance tips. One of them is that you should disable unused view engines. So if you use some of the helpers like HTML editor for and display for, these are going to look for editor or display templates, and they're going to look for that template for every view engine that you have installed. So you can save on extra misses where it's looking for a file that's not there by removing any view engines that you're not using. You can do this in your application start by setting view engines.clear and then just adding back the engine that you care about, in this case maybe the Razor View Engine. Another performance tip, and I'm moving quickly but I'm going to show you a summary of these and what their effects are in just a minute, is avoid passing null to a strongly typed view that happens to use helpers. So if you have something like HTML text box 4, m such that m.name, this will throw a null reference exception if your type that you pass in is null. Now unfortunately this happens to be the default that will be generated whenever you create a new action template. You want to create a new action, create a new view, and you're going to use the add template. It's going to do this by default. And we'll see that that has a significant performance penalty. Depending on how many fields there are, every single one of them throwing a null reference can add up quickly. So here's the default that happens. If it creates this page called model MVC music store models.order, so it's a strongly typed view. If you just return a view and pass nothing to it, it's going to pass in null. And every single one of the HTML.editor4 or display4, those are all going to have a null reference exception, and that can add up. Another performance tip is that the URL rewrite module that's built into IIS has a performance impact in MVC3. It has an impact in MVC2 as well, but uninstalling it won't help you. So in MVC3, there's a new check to see whether or not the URL rewrite module is installed, and only if it is do they then do some extra checks when they're doing URL generation to make sure that the URL is matching whatever might have been created by a rewrite rule. So if you aren't using URL rewriting at all on your entire server, then you can uninstall it and you'll get a small performance gain in your MVC3 apps on that server. So to uninstall that, you can just go to the Add Remove Programs, look for IIS URL Rewrite Module like this, and click the uninstall button. So with that, I'm going to apply some of these performance fixes real quick. I have about 5 minutes left, so I've got a test page. I've got a load test here called test add load test, and we're going to run it. And while it's spinning up, we're going to look at this controller, and we're going to see, okay, I've got a test controller, does not have output caching, passing a view with null. It's also running in debug mode, and it's also got in web config this compilation debug equals true. So once that spins up, we're going to kind of take a note of where it's at on pages per second, and we can see that it's running around 85. So the very first thing I can do is I can jump in here and I can say, no, we're going to build that in release mode, and we're going to fix web config. We're going to say debug, right, debug is false, and rebuild. And if we look at this, it's going to take it a second while it rebuilds. And there it goes. So now it's up to 100. And if we let it kind of, steady state out here, it's at 105. So we got a pretty big increase that time from turning off debug and also building it in release mode. So now we're holding steady around 100 requests per second. The next thing that we said we might do is we can go and say we don't want to pass a null. We want to pass an actual order. And in this case, it's just a new order that has no properties or anything. But if we run this again, we should see a little blip while it rebuilds. And there it goes. And we were at 100. Now we're up to 108, 112. So we got about a 10% performance gain just by passing in an instance of an order. That's fairly significant for something that was that easy. 113. So it's looking pretty good. Not as big as caching, of course. 116, it's still climbing. Alright, so then let's look at that view engine thing. In global ASAX, in your application start, that's where you'll find, or that's where you can add rather, these two lines of code to turn off all your view engines and then add back just the one you're using. In this case, I'm only using Razor, and so I don't need it to check for templates for the WebForms view engine or the Spark view engine or any other view engine. So now my build succeeded. We were at 115 or so. Look at that. We're up to 164. It's about a 50% performance increase on this page by simply changing how many view engines are installed. Not something you typically would look for as a go-to thing to get that kind of performance gain. And then the last thing we can do, the old standby, since this page isn't doing anything that requires nothing custom for the user, it doesn't even have any database access at all, we can go ahead and we can use the output cache in this case. And not surprising, that'll probably give us our biggest performance gain. We were at about 160 before we started rebuilding. Now we're up to 208, 359, so more than double. And we're peaked up around 389, it looks like. So again, biggest gains typically come from caching, but these were not insignificant jumps either, with 10 and 50% increases by doing relatively minor things to your MVC application. So with that, I think I need to wrap it up and to take some time for questions. Here's a summary. I'll make the slides available, and of course this whole thing's being recorded, but you can see here's the different things that we just went through and what the effects were. This is also the page time. The page obviously loads faster as the performance improves. And there's my summary, there's some references, and let's go ahead and see if there's any questions on Twitter, or if the moderators have any. Alright, so there's a question. With the same IE session, all assets might get cached, including database-related queries. How do you make sure that all requests are unique, because caching may skew the results during the load test? In the load test, you can specify whether or not each user should start a new session or not, and you can also dynamicize each request, each new test, so that you can specify, for instance, that a different user is used to log in. One of the things you can do is in here you can create what's called a coded test, where you actually generate the code from a set of web tests, and then within that code you can specify something like this, where you're going to say, when the user registers, I want them to create a username that's called user plus some unique string, in this case a new GUID, and this will ensure that every single user that comes in has a different unique username and email using that coded UI test. You can also, within this, you can write any code you want, so you could drive it from a database, for instance, if you wanted to. And the next question I see is, Tim Scott says, can output caching be applied to a partial view? Would that be another way to address user-specific data? Yes. Phil Hack has an article, a blog post on that was on that one slide if you check it out. The way to do that, I believe, is that you need to add the view declaratively. So you put in a mvc : view on the page, on your view, and then the output caching should work from that. He explains it very well on his blog post there that I believe is called donut caching, or in this case I think it's the donut hole caching blog post. And the next question is, how eager loading and lazy loading relate to performance? Well, it depends. Lazy loading will generally help your performance if you didn't need the stuff that you were loading, but if it turns out that you did in fact need it, then it's better to eager load it all in one request. The best performance you'll ever get for a page, as I mentioned, is if it makes no external requests at all. So if everything's in the cache, then that's going to be as fast as it can get. If it has to go somewhere and get its data, the best thing is if it only has to make one request for that data. And so that will give you the best performance, is to get everything you need with one eager fetch rather than multiple different queries. Alright, so with that I think we're about out of time. Thank you very much. Don't forget to rate the session, and I hope you're enjoying the conference, and stick around for the rest of the sessions.